All right, so that last talk session aside, or in that context, let's use some flags out here in the address list so that the user, our end users, can just enable the script and then can enable and disable the functionality without having to enable and disable the script. Um, and let's just demonstrate how to do that. And once again, we are doing this for demonstration purposes. When you're dealing with managed code like this, you probably won't package too much functionality in your scripts anyway, just by the very nature of managed code and stuff like that. So this generally, when you have just one big master script that has all this functionality, in that situation, it makes a lot more sense to have these flags. But we're going to do it this way just so that we know how to do it. And continuing on from what we were saying in the previous one, in order to do this, we're going to have to introduce sort of not sort of, but we are going to have to introduce some new instructions. So let's just go there. I don't know if that's the right one, but it will serve our purpose. So we'll start the game, link it to the process. We will go here. Which one do we want to do it for first? We'll do it for the karma because we don't have to talk to anybody or screw with menus or anything like that. So how are we going to do this? We don't need an AOB scan, obviously, because what we're going to do, sort of the basic, in order to have some value out here that the user can put data into, or that the user can put data into to signal um, some logic to our script, we have to actually have some memory space for it. So in our script, we will basically set aside a certain chunk of memory out, or basically just divvy up, or uh, cut out, or what am I trying to say? We will set aside some memory inside chunk 0 for the value that the user can mess with, and we have some control over whether, or we have not perfect control, but we have some control over how big that memory will be. In our case, we're just going to make it 1 byte because we're only going to deal with a flag that is either true or false, 0 or 1. So if it is 0, then our script will not do anything, even if it is enabled. And then if the value is 1, then our script will do something, or do whatever it is supposed to do. In this case, it will mess with the karma. So do we need to do an alloc? We do not, because as we just said, we are just going to set aside some memory inside chunk 0, and we've already allocated chunk 0, so we're not going to mess around with that. We are going to make a new comment header here and just say flags. We're going to make a new label. We are going to say flag infinite karma. I mean, I don't know if that's the most descriptive name, but we're just going to call it infinite karma. The name is unimportant. I mean, it's important from a somewhat readability perspective, but I'm not going to split hairs about it. So why do we need a label? We need a label because we are going to refer to it out here in the address list by some name, and so obviously we need a label. And so that's that. We don't need an injection point. We don't need an entry or process or return because it's just going to be some value in memory. It's not going to be a function. It's just going to be a variable. We do need to register it. Why are we registering it? Because it's global. We want the user to be able to mess with it out here in the address list. And as we've proven, you have to register a symbol in order for that to happen. Alex sort of being the being in exception, I would say. So oops, we want to register symbol, flag, infinite karma. And then because we're registering the symbol, we want to unregister it. All right. So how do we allocate space for this? The way that it is done, as we talked about, when labels are declared sort of in sequential order, like chunk 0 is some address in memory, and then just like with AOB scans and the ejection points here, AOB spend point is some address, and then we're declaring a label immediately after it, and it is just going to assume the value of that. So what we're going to do is we're just going to we're going to associate some content or some series of instructions with flag infinite karma, not Jarma, but karma with a capital K. And then what are we doing here? What we're going to do here is we have to introduce. Let's see if we can find it. It doesn't seem to be in that list. Doesn't seem to be in that list. Probably because it's not an actual machine instruction what we're looking for. It's probably just some pseudo thing provided by an assembler, of which cheat engine is or has. Um, all right, so let's go here. We'll go to Google and Google, tell me about the assembly DB command. Guide to x86 assembly at some university. Declaring static regions. You can declare static data regions analogous to global variables, which is essentially what we are doing in cheat engine in x86 assembly using special assembler directives for this purpose. All right, so the reason why it's probably not showing up over here because again, it's an assembly directive or an assembly command that is provided by an assembler or a compiler or an interpreter. Sort of, we're not drawing any distinction between that stuff, even though there is an incredible distinction between that stuff, obviously, or not obviously, but whatever. Let's continue. It's not probably not native to the processor. Is there's probably not something that it is implemented in hardware. But in x86, you can declare static data regions in x86 assembly using special assembler directives for this purpose. Should be preceded by the data directive. This is what we were talking about in the previous video. You don't have to worry about the data directives and garbage like that because you're not really writing a real assembly program. You're just overwriting existing memory, and that stuff is already sort of set up for you, and you don't have to worry about data codes and crap like that, or sections and crap like that. Following this directives, the directives DB, DW, and DD can be used to declare 1, 2, and 4 byte data locations respectively. That's exactly what we want to do over here. Over here, we want to declare a 1 byte data region, so we're just going to do that. Declared locations can be labeled with names for later reference. That's basically what we're doing up here is we're making a label so that we can reference it later and just use this name, and then we register it so it's global and it's available out here. This is similar to declaring variables by name, but abides by some lower level rules. This is true. For example, locations declared in sequence will be located in memory next to one another. Okay. Then there's some arrays, and then there's some addressing and size directives. And does it talk about these commands anymore? Probably not. I don't know. Let's do this one. Let's see what happens on this. How do I use the DB instruction in order to change this code and do not use too many move LW lines and instead, or that I may do this. The DB directive is explained in the help files as some crazy thing right there. Looks like you were trying to use it. All right, we're not going to mess with that, but we're declaring sort of a static memory region so that it's just going to basically just set it aside, and we can push values into it, or we can copy values into it, and we can set it up so that the user can enter values in, or can copy or move values into it as well from out here in the address list. And so DB says I want to basically make flag infinite karma 1 byte. And then you need to set an initial value. Our case is going to be 0. Can we maybe, I don't know, let's try this next one. Yeah, see, again, when you start looking around and reading about this stuff, you're in the context of cheat engine, you don't have to worry about any of this stuff. But this is what, when you really start looking around, this is what you're going to have to just, like I said, you're going to have to weed some of this crap out. One answer, DB define byte 8 bits. DW define word, which is 2 bytes on a typical x86 32-bit system. DD double word, generally 4 bytes on a typical x86 32-bit system. From x86, this links back to the first one we had on Google. We could do that. Do we want to do that? Let's go to this one. Pseudo instructions. That sounds good. I must have been here before. Pseudo instructions are things which, though not real x86 machine instructions, are used in the instruction field anyway because that's the most convenient place to put them. That's interesting. The current pseudo instructions are DB, DW, DD, DQ, DT, DDQ, DO. They're initialized and some other stuff right there. DB and friends, declaring initialized data. DB, DW, and that family are used to declare initialized data in the output file. We can just chop off. They are used to declare initialized data. Forget that right there. They can be invoked in a wide range of ways. You can see right here is just DB and then some hex value, and then in assembly or in most assembly languages, the semicolon is a comment. So anyway, you can see that we're not making all this up. DB is not a real processor directive, but it is more of an assembly pseudo instruction that just basically says I want to declare some value, and or I want to declare or set aside some memory region and put some value in it initially, and then from there you can basically just push whatever or copy whatever value you want into it. And if you think about this in the context of when we were talking about variables and screwing around with Python, uh, on a really low level, like I don't think Python is actually assembly. I mean, I suppose on some in the memory it becomes machine code at some point, but basically when you declare a variable in a higher level language, it automatically says here's how much space I need, and then it goes out and gets it from the OS and all kinds of things like that. When you are doing it in assembly language, none of those facilities are available to you. You have to actually ask yourself, what is the size and the range of values that I am going to store in this, and then you have to use db, dd, dw, things like that, and set aside that kind of memory, or that chunk, the size of memory that you need for the range of values that you think you're going to put in it. And if you exceed it and things like that, then you're going to be it's just not good. You're going to end up overwriting extra memory, or you're going to end up wrapping around values and things like that. So again, that's why we spent a long time talking about variables and things like that, because as we were saying, and I was trying to say back then, when you start writing assembler scripts, you got to know this stuff. And if you don't know anything about value types, value sizes, and how values are represented and broken down from decimal to bits and things like that, then it's very hard to come to you and just say, oh well, DB is 1 byte. You're going to be like, well, what the hell is what's a byte? Well, it's 8 bits. Well, what difference does that make? I want to put 10,000 in a byte. Well, you can't. Why not? Well, because you see, when you put 10,000, and then you can just literally watch the eyes roll back in their head. But that aside, we are making flag infinite karma 1 byte. So we can put a maximum of 8 bits into flag infinite karma, or you could just say we can put a maximum of 1 byte into flag infinite karma. As we talked about, for our purposes, we just want to use it as a simple Boolean true false flag. One value is going to have one meaning to our script, and another value will have another. Let's just look up Boolean here. Why do I keep saying that? Because the way that I think about it in my head is the Boolean data type. In computer science, the Boolean or logical data type is a data type having two values, usually true or false, intended to represent the truth values of something, something, something. You can read about Boolean algebra if you want. Boolean data types the primary result of conditional statements which allow different actions and change control flow depending on whether a programmer specified Boolean condition evaluates the true or false. That is exactly what we're doing with flag infinite karma. We are just going to essentially say it's a Boolean, and so if it has one, our script is only going to recognize it in two different ways. It's going to say if it is this first value, which will be 0, we will do something in our script, and we will encode that in our logic right here. Our entry functions will actually have a point going forward. And then if it is not that value, then I will basically branch, and the control flow or the execution path of our script will say, instead of doing what you do if it is 0, then go do something else. And that will sort of be the two execution paths of our script, which we will encode in the entry functions right here. And in order to do that, we need some value that we can read from and put values into, or more specifically, that the user can put values into out here. Take a deep breath, because that was a whole lot of talking. So it's okay. Let's add address. Let's enable. Well, we can't yet. We have to go in to the game. So I feel like in a couple videos back, we were moving pretty quickly through the stuff because we had built up a good foundation and we understood it implicitly. So, it helped out a lot. We didn't have to stop and say, well, here's what this is and here's what that is. And we pushed forward to a point to where, in order to build this out and bolt more functionality and be more user friendly and things like that, that we just sort of have to sit down and be like, there's a whole bunch of other crap that we have to talk about. And so that's why we have to sit down and just talk. So there's that, and there's that. So we've pushed that stuff into memory. So we'll come back out here. We will add, now we will enable the karma script. Let's make sure all that stuff's in there. Flag, flag, flag. Yep. So let's enable our karma script. It does the AOB scans. It finds things. It enables. And now it's sort of, what's the next step? Well, the next step is that we have to put the actual flag out here in the address list. How do we do that? You just go to add address manually and you type in whatever you named it in the script, which we did flag infinite karma. And you can see it's, what's this value? We initialized it to 0. Yes, we did. However, we did it as 1 byte. So what Cheat Engine is saying, or what it's doing by having 4 bytes selected, is it's saying I'm going to wherever this memory location is, and I'm reading 32 bits. However, we basically declared flag infinite karma as 8 bits and zeroed it out. So it's saying the first 8 bits are 0, and then the last 24 bits have some random bit pattern, because that's just how memory is. You never know what the value is, and that's why you set initial values and things like that. You can never make an assumption about it, so you have to do it explicitly. And so if you change the type to byte, it goes to 0. If you wanted to make a more visual representation of that, you could do something like this. Haven't used Notepad in a while. So there's 8, there's 16, 24, and 32. What's happening is that we have essentially sort of, this is our variable right here that we declared, but Cheat Engine was saying, yeah, but I'm treating it as 4 bytes, so I'm reading these 32 bits instead of reading just the first 8 bits. And so when you tell Cheat Engine, no, not 4 bytes, 1 byte, it's saying, oh, okay, well, forget these 24 bytes out here. Bits is what I should. Forget those 24 bits. So that's sort of a slightly more visual way. And you can see too that there's an actual address associated with our flag. So it really does have a memory address. We really did set aside some space. So let's say flag infinite karma. So you can enable it and disable it, but it's just a value. So doing this is, you're doing nothing. It's just a waste of your time. But I suppose it would freeze the value, but this value is only used in our script, so freezing it is kind of pointless. So let's change the value. Well, our script is not wired to check this value in any way. It's just, it recognizes this value as flag infinite karma, which is this address, and it is set up and it is torn down in our script. So let's disable the script, and the value goes to question mark, because this address no longer exists. You'll still see it, but if you double click on it and then you go to flag infinite karma and you hit OK, it'll just go back to whatever you're telling it to look, whatever you named it, or whatever you are telling Cheat Engine is the name or the symbol to go find. And because we disabled the script, the memory region this flag was in with chunk 0, and then we unregistered the symbol as well. I don't even know what that is, as evidenced by the dealloc and the unregistered down here. So if we re-enable the script, it'll suddenly come back. You can see it comes back. I don't remember if this is the exact same memory address or not. It may be, but it's not important. But you can see now the value is 0. So let's disable it again. It goes to a question mark. Let's make the initial value 1. Now let's enable the script. You will see this value, instead of being 0, will be 1, and that sort of beyond any reasonable doubt proves the connection that we have between our script and our flag. And we are going to stop it here and get into the compare and the conditional jump assembly instructions when we come back in the next video.